So what was the water to land transition? So this was the transition of vertebrate organisms in the late Devonian epoch. And this was preceded by plant and invertebrate terrestrial invasion, which allowed for the establishment of suitable habitats for tetrapods. And the fossil record of the transition to land in tetrapods is extremely poor. And this transition also posed numerous physiological challenges to early tetrapods. So the key dates were late Devonian mainly, during the Flaminian stage, and that was around 382.7 to 358.9 million years ago. That's just for the whole of the late Devonian. So tetrapod evolution occurred mainly during the Flaminian stage, and the first tetrapods appeared in the late Devonian around 367.5 million years ago. There were two substantial extinctions during the late Devonian as well, so that took out quite a lot of marine animals. So originally this transition was unclear, as the fossils of the earliest land tetrapods were known from rocks dating around 363 million years ago, whereas fossils of lobe-finned fish were found in rocks dating back to between 390 and 380 million years ago. So there was this gap of 20 million years where there was just no evidence of the groups between the lobe-finned fish and the earliest known tetrapods. So we will start with one of the most basal members of the tetrapod lineage. So Eustinopteron was a lobe-finned fish found in the Frasnian aged rock in Quebec, and that is late Devonian, around 385 million years ago. Eustinopteron had very similar features to the earliest tetrapods, such as its pectoral and pelvic fins. It also had characteristic teeth, which is similar to that of modern amphibians, which is known as labyrinthodonts, and that means that their enamel is folded. They also had internal nostrils, and the bones in its pectoral and pelvic fins could be analogous to that of our limbs. So, for example, the humerus, radius, and ulna, and the tibia, fibia, and femur. So, there's been over 2,000 Eustinopteron specimens collected in Miguacha, which is a really good fossil locality from Quebec. And it was thought that because of the fins, they used the fins to crawl onto land, which was therefore the link between early tetrapods and Eustinopteron. However, more recent research has suggested that it would have lived solely in water. So next we move on to Panderictripods, which was found in late Devonian rocks of Latvia, and they're dated to around 380 million years ago. The overall size of specimens is around 90 to 130 centimeters long, and it's thought that it's thought to be the sister group of the earliest tetrapods, and this is because it shows a range of transitional features between lobe-finned fishes, e.g. Eustinopteron, as well as early tetrapods. So it had an elongate snout with a flattened skull, as well as eyes on top of its head. And really cool thing about this this organism, is that we have fossilized trackways of it, which was found in 2010. And these fossilized trackways kind of suggested and pushed towards it not really being a direct ancestor of tetrapods, but it shows traits that evolved during the fish to tetrapod evolution. So we then move on to a more advanced tetrapod known as Ichthyostega, and this was a primitive tetrapod from the late Devonian, which is around 365 million years ago, and it was around 1.8 meters long, and it's still classified as a lobe-finned fish, but it had similar features to the earliest tetrapods, such as broader, shortened skull than Eustinopteron, and it also had fish-like features such as no true elbows, knees, or wrists or ankles, as well as long fin rays around the tail, which is shown in this diagram here. So it's kind of got sort of like an axolotl-esque or a newt-esque tail, And its tetrapod-like features is the head's not attached to the shoulders, so it meant they could do more movement of the head. As well as this, the ear is fitted into the brain case instead of being elsewhere. It's got a large pelvis, as well as sacral ribs, and the femur is as large as its humerus, so that's really interesting. So the most interesting thing about Ichthyostega, I think, is that it's got 8 digits, all linked by webbing, and it lacked wrists. So it's possible that it could walk on land, but the morphological features suggest a solely aquatic lifestyle. This is because the spine and the ribs weren't really adapted to support weight on land. The legs kind of lacked the joints as well as the motion required for locomotion, and the front feet of the Ichthyostega could not bend forward at the elbow, which meant they couldn't really go into a weight-bearing position. As well as this, the Ichthyostega jaw was kind of more geared towards feeding underwater, indicating that it is more aquatic. And also, it's been found in Devonian river sediments in Greenland, and which again is really interesting because it is an aquatic animal, and it is most likely to be carnivorous. And then finally, we move on to Ichthyostega, and this is thought to be one of the most important transitional links between marine and fully terrestrial vertebrates. It's one of the first tetrapods found in the fossil record, and it's a late Devonian organism dating to around 363 million years ago. It was 1.5 meters long, and the really interesting thing about Ichthyostega is that its lungs were surrounded by large overlapping ribs, which formed sort of like a rib cage, and this allowed for Ichthyostega to spend more time on land without suffocating under its own weight, as the spine was now stronger as well as the ribs. And also it's really interesting. It's got 7 digits. And it's most likely that it moved around on like a mud skipper on land, as its hind legs could not support its weight. Really, it couldn't really walk around. So again, Ichthyostega was found in a Devonian river sediment in Greenland, and again was most likely to be a carnivore. So although all of these organisms helped with our understanding of the development of the water to land transition, there's still this sort of missing link where fins have suddenly turned into hands and limbs. So for a good, a long period of time, we were still waiting for this fossil to be found. And this question was sort of answered in 2004 when Tiktaalik was found by this gentleman over here. His name is Dr. Neil Shubin, and he is from the University of Chicago. And what they did was they went over to Ellesmere Island in Canada, and they looked in late Devonian river sediments, and they found this really, really, really cool fossil where it showed characteristics of both fish and tetrapods. So this is Tiktaalik. It is an amazing fossil. I would definitely read up about it and just be amazed on it. When I first learned about it, honestly, I was amazed. So it's late Devonian, and so it's 375 million years ago. It's around 1 meter long, and it's thought to be the missing link between fish and tetrapods. And this is because it has both fish and tetrapod characteristics. So, for example, it has this limb structure where it's got the tetrapod limbs, but it also has a fin. So the limbs turn into a fin. It also has this key number of 5 digits, but these limbs weren't really suitable for walking. However, it could push itself off the ground. So people, when talking about Tiktaalik, often say it could have done press-ups, which I think is probably true. So over multiple specimens have been found, so around 20 different specimens have been found by Shubin and others, and quite a lot of different growth stages have also been found. So unlike fish, Tiktaalik had a neck, which means it could move its head without having to move its body as well. And the rib cage was very similar to Ichthyostega's, which meant that it could protect its own body from collapsing on itself, and it could come out to land without its body crushing itself. And on top of Tiktaalik's head, they found holes, which are thought to be spiracles, and these are connected to the lungs, which would have allowed it to stay out of water longer. So these features in Tiktaalik showed that much of the morphology that we associate with the earliest tetrapods first evolved in the fish. And so as shown here, so we've got a key example of a tetrapod, such as Ichthyostega, and then a fish, and then Tiktaalik in between. So it's like an intermediate organism between fish and tetrapods. So Shubin calls it a fishapod, which I think is really cool. So Neil Shubin quoted saying that overall the mix of fish and tetrapod characteristics on Tiktaalik show us that the structures and mechanisms necessary for the invasion of vertebrate life on land evolved in water first, which makes sense to me anyway. It makes sense in the paleontological record as well. So, and then here is a pretty simplified phylogeny with kind of the key organisms here. So, and then this is a meme that was one of my favourites, and it has been, and it makes me laugh every single time. So it says, Tiktaalik walking onto land for the first time 375 million years ago, fin will be leg, our evolution will be legendary. So I don't know, it just makes me laugh every time I see it. So problems with life on land, I mean, other than what we've done now, there was a lot of problems with life on land for the earliest tetrapods, and these all needed to be rectified. So reproduction, it was kind of thought that during the Devonian and with the earliest tetrapods, the reproductive style of organisms such as Ichthyostega would have been similar to modern amphibians. And this is shown in the fossil record from the Carboniferous and the Permian. And then during the Carboniferous, we kind of get the evolution almost of eggs and the amniotic egg. Respiration is another key one. So it's assumed that early tetrapods used similar breathing techniques to amphibians today, and amphibians today use this thing called buccal pumping. However, quite a few of them retained gills to allow them to breathe in a fish-like way. Another one is the sound reception. So it's thought that these early tetrapods had a really poor sense of hearing on land when compared to water, and supporting their own body mass. So this is kind of a key one. So the paired limbs of the Sarcopterygians already kind of had the right bones and muscles to allow for locomotion. And so all these organisms had to do really was just modify them a bit to allow them to walk onto land. Which is really cool. I mean, it's such a interesting transition that we still don't really know that much about, and there are new fossils being found every single field season that, you know, might change this whole phylogeny and change everything that we know about this. And then, so finally, I leave you on the further reading. So another bit is like podcasts and videos. So the Paleocast on Tiktaalik, the second one down on the left, is really great. I re-listened to it on Friday on my way to work, and I think you should I would definitely recommend it to you guys, as it is really interesting, and it talks about how Tiktaalik was found and like what led to that. And then also the You're in a Fish book by Neil Shubin, that is a key one. That was one of the first paleontological books I read. And it's, again, similar to the Paleocast, where they talk about what he did, but it also goes into more detail and also like how we are as humans, which again is then linked to the You're in a Fish documentary, which you can find on YouTube and or anywhere else that you get your documentaries from. So on YouTube it's a 3-parter, and I think it was the same when watching it on the telly. And so you have You're in a Fish, Neil Shubin, then you have You're in a Reptile with Neil Shubin, and then you have You're in a Monkey with Neil Shubin. So it's a really, really interesting topic that quite a lot has to be said on it. And I'm just glad that I was able to talk to you guys about it, as it's something that really interests me and always has done. And so here are the references. There are probably a lot more, but they're always on the further reading and reference sheets. Image references as well. And then you know where to find me. So yeah, I will look forward to seeing you all next week. Please get in contact if you need any help and or have any comments, just let me know. So yeah, I'll see you all next week. Bye guys!